Welcome to the third episode of our second season of the Kern Competence podcast. I am once again joined by my co-host Simon. Simon, welcome.
Welcome, Marvin. Thank you.
Our last episode had quite the feedback on the internet. Many people wrote me on Instagram. I guess it was to be expected after you dropped the big bomb at the end of the podcast, telling everyone that we're going to launch a new machine. Now, we got quite a few questions over Instagram from our listeners because something you and I completely forgot last episode was, why is it called Kern Fortis HD?
Yeah, that's a very good question. And the funny thing is, this was an odyssey. So we went through many options. And so as a German, so we have a very famous monastery around the corner here, which is also a school for boys and in the meanwhile, boys and girls. My youngest one goes to that school, and the first thing he learns is Latin. So Latin here in the region is also very important. So if you're looking for a name, you first look into Latin. And we had many options, and we looked into, for example, Magna. That was my personal favorite at the beginning. But our product manager, Verena Höck, she didn't like it at all and said, so no, we're not going to take that. So we backed out of that, and we had many others like I think Xenos, and Magna, of course, means big. Xenos this is something new, a new sphere kind of a thing. So it's both room and innovation whatsoever. And we had some Greek things too. And at the end, we went for Fortis. Fortis means strong, Fos Fortis in Latin, and also has different meanings, goes back also into the Greek part. So being big, being strong, being I should say, bold. That's the right explanations. And so therefore the team at the end of the day decided this is the best choice. Of course, also, as always, a little bit of a compromise. But at the end, that's giving something a name is really difficult. There have been many mistakes, famous mistakes in the last decades, like Porsche Cayenne in, for example, Spain was a total failure, or the Touareg, which is a bad word in Spain, for example, too, and was a car by VW, by Volkswagen, and so on and so on. So many bad mistakes. And so we try to be on the safe side, but nevertheless being bold and hearing the name directly, knowing what you have to expect. And with Fortis, I think you're not expecting a tabletop machine. Huh?
Probably not, yes. The moniker HD was, of course, kept on this machine as well. This will, of course, show it's a similar, not the same, but a similar technology to the HD. So our customers can once again expect a flawless motion system.
Funny enough, I often said our strategic development is based on this non-friction hydrostatic with integrated linear drives. And so therefore the HD, which we have in, of course, micro HD or micro HD plus, and which will also be the main principle in the Fortis HD. Yeah, completely right.
I think this is going to be the first machine of that size with hydrostatics, isn't it?
Wow, I'm not 100% sure, but what we can say is this wasn't a project that now went on for 3 years. It's really so we started it 7.5 years ago. We're working on that since then with full throttle most of the time. So even HD plus, so we had to handle aside of that big project also a lot of effort, and of course also money went into it. And what we know today is that this is the biggest kind of size for an X system with that kind of principle. That's what I heard back from Matthias Fritz. So if we want to go bigger, so we need to have something else, also new construction, new principles in how to design those X's. And it's not exactly the same, to set it crystal clear. It's not going to be the exact same X design as with a micro HD. If you look at it the first time, it's totally different. Shall I drop something? So
Sure.
the so it's the same material, so it's aluminum, and the X system, 3X system of a micro HD is roughly 360 kilos, including hoses and so on. For Fortis, it's gonna be close to 2 tons. So
That's quite a difference, and I think people
yeah,
can start to imagine what sort of machine this is. Um, you said 7.5 years of development. Maybe let's go back 8 years to the drawing board, because this is a strategic development. So at Kern Mikrotechnik, we have two developments. We have an operative development, which takes care of the serious machine, because sometimes we need a new spindle or there's a new MQL system being integrated. So we have a development department taking care of these in serious changes. And then we have the strategic development, which is headed by Matthias Fritz. And they do the, for example, new machine or new product developments. Talk us through it 8 years ago, or maybe even more, when we started this project. How did we pick it up?
Short story right before I answer the question is in the town hall meeting, I think 2 or 3 weeks ago, I said, so in a company, you have to make decisions every day. And many of those decisions seem to be super important, big, and will determine the future. And actually, at the end of the day, of course, they all pay into a certain path that you choose, but what was really important is the decision we made at that time. And I can still remember sitting in Austria with Matthias Fritz and Sebastian Guggenmoos and Sebastian Wühr on a table, and we were discussing 9 options. So it was 8 that we really discussed. 8 possible paths to go in portfolio management, product management in the future. And we choose the one, which is today Fortis. And I can say all 7 other choices would have been a failure. So it wouldn't help us in the situation right now. It wouldn't be on point where we need to be and what we need to do and what we need to develop the company further, the current community and so on. So making this decision right was extremely important. And saying a failure is most of them wouldn't have been big enough. So if you make so HD Plus is a nice next step, and really the machine is great in performance, but it's not going to carry us for the next 10 years alone. So if you want to grow our market, our relevancy, so we need to be where customers want us to be, and that is the answer to the question. Our number one source for innovation and determining the way we want to go in the future is the customer. And how we do that, so for example, we don't do test cuts, or we try to avoid it like the devil avoids holy water. So because actually we don't learn anything from it, and it's a one-way kind of in intelligence, respectively, information flowing in one way. So we do something, you just get the part and whatsoever. So we don't learn from it, customer doesn't learn from it. So what we do today is really having workshops. So everybody puts his knowledge in. So we learn what customers know about the material. We learn about how they run processes, and we can jump on that and see, okay, well, we can do it better. Or we come to a point where once in a while we see, okay, we're struggling with that because of, for example, our mechanical limitations, or because of the fact that the machine doesn't have options. So I would say automated tool cleaning is something that fits in here very well. So we saw, okay, this is a constant struggle. So we have to develop something. We see what's there. We try to make it adapted for the current machine and what we know what is necessary. So in very just few instances, we take standards from the market, like for example a beamer nozzle to automatically adjust your flood coolant to the tip of your tool. For example, this is something that's there, just needs to be integrated. But tool cleaning, for example, or many other things like um, everything around spindle, around the laser, and tool management and so on. This is something that we need to put ourselves in. One of the best examples is the CSC spindle, for example.
So the compact shaft cooled spindles, where you have shaft cooling, which improves the thermal behavior of the spindle by nearly an order of magnitude.
Mm-hmm. And so when we heard from the manufacturer, yeah, just integrated, so this is more or less a standard. This is the aggregate you have next to it that supplies the spindle with right amount and, of course, right temperature of coolant. We immediately figured out that this is not good enough for us, and there's an upside potential. So it took us 1.5 years to come up with a spindle that actually is so well controlled also in temperature-wise that we have a big differentiation, even versus the other manufacturers using more or less exactly the same spindle but in different way. And I think that makes the difference for us. That's our biggest source of innovation, being in customer shoes every day, also in contract manufacturing. And coming back to Fortis or Albatros, how the project was named. By the way, there were some voices that said, why don't we call it Albatros or Albatross? And the Americans told us this is not good. There's a tale about albatross being a bird, and bad stories, and not very well perceived in some parts of the world as a name. Exactly what I said before with Tuareg also.
It's, when we started here with the project name and went around the company, I actually asked the development lead on this machine, Christian Meyer, asked him, like, why are you calling it Albatros? In mechanical engineering, most projects have like dangerous and quick names like Tiger or Gepard or Gorilla.
My suggestion was Titan.
Yes, exactly. So usually it's something which is manly and strong and quick. And he chooses a bird that has problems lifting off. And then he laughed and he was like, doesn't this describe every current project ever? And I was like, this is bad foreshadowing. And then he was like, but once it's in the air, it can actually stay up nearly unlimited. And this is what we are aiming for. It's like, okay, nice turn around it. And something which obviously is also a part of the company culture is, so for example, on the Fortis, on the first one, which has been running for more than a year now, if you boot it up, it shows an albatross when you're booting the machine up on the screen. And there's like a little albatross bird stuck with glue to the control panel. It's just like people took it on, and I've seen many presentations with different artificial intelligence generated birds on this. It's been great fun there.
That's pretty nice. And by the way, also this decision has been made in a democratic way. So I didn't want it to be Albatross, but they decided. So now we're living with it since 7.5 years. Until we finally launch it, and it's going to be Fortis. So we need to be disciplined on that to call it Fortis, because that's the biggest problem. You're going to keep the name for the next 3 years, even if it's just a project title. So Fortis is it.
Let us backtrack a little bit to the voice of the customer. You mentioned that we are not a huge fan of test cuts. So for our not completely familiar listeners who haven't bought a Kern machine yet, a test cut is basically when you send us a drawing and we send back a finished part. I think the industry considers this kind of the due diligence on a new machine purchase, because then they are like, well, the machine can do it. I'm always unsure what people really want to do there, because it's also for the customer kind of the laziest way of checking whether the machine can do it, because they can't see what we do to produce this part. Is it a special machine? Did we change something on the compensation of the machine to achieve that result? Something which like 20 years ago was totally normal in the industry and on lower precision machines still is. If your position is not okay, you start moving positions on the model. This is what everybody is doing. And I have never ever moved a position on a model. And we also don't do it on the HT. Like in customer workshops, where the customer comes in and we work together on developing the process for the part, we don't do this. And a lot of customers are skeptic about this process because they are not promised to go home with a good part. But I always promise them you're going to go home with a fuzzy, warm feeling that this is the correct decision. Because you start up with them and we kind of like prepare a little bit. So it just starts with a bit of momentum, the workshop. And after like 2 or 3 hours, you see, okay, they start understanding, okay, we can do their part, but then they want to see things. Then they are like, hey, can we drill a hole? We always had problems with like concentricity when drilling, and then you just do it with customers. They get so much more insight into the machine. Obviously, they need to understand the technology, they need to be here. So it's a couple of those things. This is one way customers can input their voice into our development and where we learn. But obviously, this only works if you come in for a workshop, and you kind of can't register for a workshop to give us input. So, Simon, what do you suggest to our customers, to our potential customers, if they want to give us feedback, if they want to reach out to us to tell us something? Which channel should they take?
So I would say, if you like it or not, so the biggest source of customer input always is sales and service. For me personally, being with customers, seeing their manufacturing, and so in the meanwhile, I'm in a super privileged position to. I'm not sure if anybody else in the company has seen as many customers as I have, because I'm very often co-traveling at least once a year with every single one of them, and we select, of course, interesting customer, but not necessarily always the biggest. So you get a very good feeling about where you are today, and you might even, when you visit prospects, get a feeling as to where we want to go, or where's the market, the industry going. And this is at Kern, as you know, it's not like with many others that we are super specialized in one industry like automotive or mold and die, but we try to be very broad and flexible to not come into any kind of dependencies and stumble into crisis, not because of our fault, but because an industry is going down. And let's go back to Fortis. So if you've been in the negotiations and or talking to customers, been part of workshops, and I try to at least talk to every single customer that comes to Eschenlohe here, and you get a pretty good feeling. And of course, what they say is, we're struggling getting our parts into micro HD and so on. So we have a super big customer, which I cannot say, and they right now redesign their parts to fit on a micro HD, and this is a little bit awkward, no?
I think this is a massive win for our technology.
yeah, it really is. That they truly believe, and I hope they're right, that this, ours is the only machine that can actually do it. So they have no other choice to actually redesign and put it on our machine. But of course, that was easygoing to say, okay, there's a demand. But now the big question is, you can see that people would like to have a bigger machine, but what's the trade-off? So what do you need in a bigger machine? Is it you need different kind of spindles and so on, or is it the same kind of spindle? What do you need in terms of automation? What are you willing to pay for it? Are we able to do things like that the current way and still be relevant on the market, fitting value and price together? And we do a lot of things after that, which is, I would say, also science. It's not like algebra or something, but it's coming close. If you know your tools, you know what you're doing, you can figure out and determine what the details are and what the product needs to be to, at the end, be successful. And today, just very shortly before the announcement on the EMO and showing the machine the first time, but actually seeing its performance in over a year now, okay, this is going to work out. And of course, we also have the one or the other customer coming in, and we double check at first, of course, the concept when there was nothing there, but also today, the final machine then, and see how things moved and changed. And always keeping in a design control grid, but you will have, I guess, a second podcast with R&D. You say, okay, well, what do we put in a design control grid? It's really like the recipe for this machine. How good does it need to be? What is the measure? Everything needs to be measurable at the end of the day. And if we trust the process, if we do our work right, and have the right also relationship and openness to customers, then yeah,
I mean, I remember
gonna be good.
very well when we started actually using the machine. It's now, I think, more than 1.5 years ago that Christoph Staltmeier and I did the first chips on this machine. And it's quite funny because it had never ever taken a chip before. So, for example, with the HD, when we developed that one, the very first chips on like the HD were actually me milling into the housing of the swivel axis to make room for the laser, because it had like a slightly different design. We upgraded to new LC50 laser, and it was the old swivel axis for the Plume NT laser. So the first chips on the HD were actually not very spectacular because it was a machine without enclosure. But on Fortis, it was actually the very first chips was a complete machine with like enclosure, with flood coolant, with a working spindle, with a working tool changer. And we decided, okay, now is the time. We just need to start making chips. We need to see whether it works. And I remember very well, we have videos of this. So I think at some point we're going to upload the videos of this as well. I kept the material. But it just like it started milling and everything worked fine. And something we had to consider on this development for the first time is chatter. So chatter, where actually the whole machine frame excites itself. So not chatter in the sense of your tool is vibrating, but because micro HD is actually too small to excite the machine frame. But Fortis is big enough that this is a relevant risk. And development has done lots of clever design to mitigate that risk, but we didn't know it. And we had like a large end mill in it, and we slapped a piece of aluminum on the table, and we started taking chips. And everybody was holding their breath for like half a minute. Also because I told them like, hey, we are recording sound, don't say anything. And then they just ignored the don't say anything, and everybody started shouting, and there were high fives going around because the machine was super stable. It was already like, hey, it actually works. And I think everybody who has ever done a DIY machine at home knows the first cut isn't always promised to work out. So that was really nice.
There was also a funny story with, so I was talking to Matthias Fritz and said, can you still remember the discussions we had with the first micro HDs launched into the market? And we also did testing in our contract manufacturing, and we had a machine here for quite some time, but not as long as Fortis right now. And actually, we had a 6 months, I would say, very weak sleep at night because you never know. So what we are expecting is that the system may fail, so something's wrong. The access will not work. We will have contact or something like that, and the access will wear down very quickly. And actually, till this day, to reset that because it's really now quite some time, and we have I don't know how many hundred machines, micro HDs out there. We're thinking about adding a 10-year warranty to the access system because of the fact that we haven't had a single failure ever since. And this is what we felt with Albatross, what you said, or with Fortis at the beginning. And right now we also know, so that is the advantage. The principle is known, so we know once it works for 500 hours or something like that, we're not going to expect anything later than that. So it's going to work out. Where freeness is determined relatively quickly with a machine where the system is 2 tons. And that makes it a little special, but still there's excitement, of course. We want to get every risk out when we launch it to the market. So therefore also we're going to have a limited launch next year because of the fact that we will have limited capacity. So in 2026, we overall just have 5 machines, and we will keep at least 2 of them here for heavy testing, and have some selected customers until we ramp up then. and also ramp up with this machine is different. So with micro HD, so you might not know, but micro HD as a platform machine with Vario, also micro Vario, micro HD, at that time, we had to determine what's the mix. And we were super wrong. So I'm usually known for making decent plans. So I always claim I'm never wrong. I always hit the plan. In this case, I was totally off. So the sales reps also had to determine, okay, how much is HD, how much is micro Vario. I pulled that slide up. Lately, it's 10 years ago. And we were all wrong. We said it's going to be 80%, 60% micro Vario, and the rest is going to be HD. Truth was, next year it was 95% HD. And at that point, we could switch because the platform's the platform. Of course, there was struggle, and of course, we needed to put a lot of energy into to make that happen. But this is something that's not going to work with Fortis, I can tell.
Yeah.
It looks similar, but it's a different kind of animal.
I have to say, I wasn't at Kern when you did the plans for HD. I basically started when the first one was put together. But as a machine operator, I have to say, when you're standing in front of HD compared to Vario, and don't get me wrong, Vario is a fantastic machine. I mean, it's the Kern machine I started working on, and I was so amazed by the precision. And still, it's a machine you can do 2 microns on the part easily. But when you stand in front of HD, everything is just perfection. It's so smooth in terms of how the axis system works. And it's not something you can actually see. I mean, if you put on the oscilloscope and you move in like a diagonal line, it kind of looks the same. But just like your eye can detect whether, for example, your smartphone video is stuttering or not, you can see when you stand in front of the machine when it's just like frictionless, when the movement system is finished, when it's like perfect. And I just spent 2 weeks doing the first sample part for Fortis. It's sitting right next to us in your office. And I have to say that exact feeling happened. I sometimes, for fun, mill on very big German machines at a friend's contract manufacturing. So I know how big machines move, and it's different to obviously how a small machine moves. And then you stand in front of Fortis and you watch it move, and it's kind of like, it's that HD feeling. It's not rough. There's no jitter. There's no noise. It's just like the machine is moving. And we took a couple of cuts where I think the majority of the industry would get really sick and afraid of us on that machine, and they were completely silent. The compressed air was like the loudest thing on the machine. Mm. And that's so special. So I think Fortis is going to be, it's in the people who come and look at that machine and see it work, it's gonna create the same want that you just want, that perfection. So yeah, I think we're gonna be surprised with the amount of orders we get for that one as well.
Yeah, that's what I'm a little bit afraid of, because we don't want to disappoint people at the beginning, but let's stay humble. So we will see how many sign up for one. But that's what you just said. So we have a machine on the shop floor right now, I think, or it's even 2, a micro HD with air bearing spindle, and this is magic.
Yeah,
because you hear nothing. The only thing you hear is chips flying around. If you do small stuff, you hear nothing. That's really great. You don't hear the spindle. You don't hear the machine. That is quite a nice impression. Totally different. And you're right. If you see the big machine moving and making chips, so that makes noise. But once you're in detailing and things like that, then you see it's really completely silent, and this is opposite of what you would expect from.
Yeah, but I mean, not only on the finishing. If you remember, 2 weeks ago Friday, when we were in front of the machine, and I was semi-finishing with a 20mm end mill, and you couldn't hear anything. And there, the chips were like long chips, and it was really taking a beefy cut. It would have been a cut the HD would have struggled with, and the only thing you could actually hear was the compressed air, and you couldn't hear like the machine ringing, and there was no vibration, because once again the heterostatics are so amazing at dampening. And this is something I think every similar sized machine from a German quality machine tool company or any German quality machine tool company would have been loud as hell on that cut. It was just like silence. That was really nice.
Pretty cool. But tell us a little bit more about the test part, if you want, you did for Fortis.
Yeah. So I think we should probably mention what the part is, right? So last year we had a show part at AMB which was called an optomechanical housing. The idea being, and our test or our sample parts are typically very close to customer parts. Obviously, we can't do the customer parts, but when we see an increasing volume in requests for the same market segment, we decide, okay, let's do a sample part on this one. This is also because we start to understand what is important on these parts. And basically, optomechanical housings are optical assemblies where the idea is the precision actually is in the structural part and you do as little as possible adjustment on the optical setup. You need this whenever you, for example, want to fly something to space, when you want to put it on a moving object. So once you leave the lab setting, having small fiddly screws to adjust something is usually a bad idea. And we did this optical housing because we also wanted kind of like a large part to show on the HD. And that part it was made basically in the largest size the HD feels really comfortable, where you don't have to pay attention with the tool, maybe do a 5-axis movement with the tool to get into an opening. This was the maximum size. And in our sample part plan for Fortis, we decided, okay, let's do this part, but scaled up. Scaled up to the maximum size you can actually do on Fortis. And this raises a couple of problems I didn't really realize when I designed the sample parts and ordered a couple of tons of aluminum for this. I'm way too weak to lift such a part into the machine. This is, I mean, okay, I'm not really a strong person, but on the HD, I can just like lift everything with one hand into the machine, or at most 2 hands if it's a large device. And there, I can't even move the block. Like if I push with my whole weight against the block, it's not moving. So it started out there. And then we actually started roughing it. And it's kind of funny because on the HD, the roughing took quite a bit of time on that part because you were using large tools. And I kind of expected the roughing to take a long time as well. And well, 1.5 hours later, more than 100 kilograms of aluminum are in a chip bin. We have a chip conveyor on the machine, and there's like a large professional quality chip bin on it. And I was like, how do I empty this chip bin? So it was a lot of new learnings to me. You can pick it up with a forklift and then tip it over. It has like a mechanism for that.
We don't have a container, actually. Yeah.
No, we don't.
Yeah.
So I first had to get a container for that one as well. And the containers we got there are like Euro pellet size, and it's completely full with chips. So I was like, we need another container, and urgently, kind of. So yeah, these are the beginnings of the struggles. And then you actually start milling, and I mean, I haven't milled on it for the past 8-9 months. It was mostly Christoph Staltmeier milling on it, doing a couple of customer workshops on it already, doing lots of testing on it. And it's kind of like, I mean, that feeling of it being super smooth, it still consisted. At the same time, it completely felt like an HD. Felt like an HD, just like massively larger. It was just so cool. The strategies you're able to do on an HD, doing like super small throttle idle movements, to have nice cutting conditions. Everything is possible again. It was really cool. And then when you start finishing, it's moving in the same way and you can apply the same strategies. So it was really a lot of fun. And I think everybody who has ever operated a machine themselves knows scaling up a part doesn't scale up your cam system. So you kind of need to program it anew. And I kind of knew the basic strategies, but everything kind of worked out. And we actually managed to do 2 housings. One very pretty, which is going to be at EMO. And one with a couple of holes that are too deep on the mounting, which is going to be shown on the open house day. And I think once people see the difference in these 2 parts, I mean, you can see it every day from your desk, the difference in size on these parts. It's insane.
Yeah, but it's not sitting on my desk. It says on a heavyweight kind of a, so how do you call that?
A trolley.
A trolley,
yeah. Yeah, exactly.
But that's going to be pretty cool and should, so even if you don't see the machine, you understand what we had in mind. And I think what you just explained would go back very well to the design control grid and things we put in that need to be. So actually, that was the idea of Fortis, is have an HD in a different dimension. And everybody who's in mechanical engineering and so on, even different parts, knows it's not just like scaling it up. You need totally different principles and construction-wise approaches to nail things or problems that you nailed years before, and you start all over again because it's not going to work out in another dimension. And so that's what the team did very well. But I think we will talk about that at a later point in time and share a little bit more information and on accuracy, on speeds, on all the specs that you want to hear. But I think what we did is explain the, how do you call it, innovation cycle, or how we came to that point, why we are so sure. And I think we have so many customers also around us that are friends. So, like for example, today there are 3 customers there. I have a deep connection with them, and they will tell me what's good and what is not good, and learning from that is I would say, most valuable source, even if it's not 100% of what you need to know. So articulated, unarticulated. So you need to do your, I don't know if that translates, transplantation. So you need to do the transfer into the current environment, what we are able to do, and so on. But once we have the deep understanding of market and especially customer, then we can do the right things. And I think that's what we prove with HD Plus, and hopefully also with Fortis in the future.
Yes, I think we're very well prepared for it. We are kind of at the end of this episode. Let's quickly mention again upcoming events. Chicago Open House Days.
Yeah.
So if you
It's going to be beginning of September.
Beginning of September, reach out to your current sales manager if you want to come. Probably best choice. Exactly. And then middle of September, we have the EMO trade show in Hanover. It's Europe's largest machine tool trade fair this year.
I think still the biggest in the world, isn't it?
Probably still the biggest in the world. I'm always surprised by like the whole building with bandsaws. Whenever I stumble into that building, I'm kind of like, wait, I'm wrong here. And is the complete building bandsaws? Yeah. So yeah, it is a large show. It's well worth visiting. Kern is going to be there. We have the largest booth ever, I think.
Yeah,
most expensive one ever as well.
5 times in a row we made that. we are in the middle of the Shark Tank as always. Yes. So I can still remember the times they said, "Oh, we're gonna be as far away from our competitors as possible." So right now, the first thing we look at in the fair and events team is, how can we get closer to that?
It really is like that. We're going to show 3 machines. There's going to be an HD Plus. There's going to be Fortis HD.
Yes.
And the femtosecond laser machine.
Yes, also. So we see this is, I would say, the most important products in the categories we're supplying in. Femto 3, as it said, that's constantly making development also with the customers we're having, and HD Plus, of course, you just saw the machine on A and B, so we weren't able to put it on IMTS because we just had one machine and we couldn't ship it to the US so fast. Otherwise, this is still my favorite fair in the world, I have to say. So IMTS is just like vibrant and there's so much energy there. It's going to be a little bit different. It's more, I would say, engineering kind of driven at EMO. That's how I would call it. That's a little bit different. And but showing HD Plus, showing parts, and so the real machine, not a prototype, but machine number, who knows? So you can really have a look and see the machine in action. And of course, biggest part, and therefore we need again a bigger space, is then Fortis HD. So I think fair to say it takes half of the booth. It's just the machine.
Yes. Yeah. Okay. Awesome. Simon, thank you for your time. Until the next one.
Thank you very much. It was big fun.